Next one is we're just going to see the stack applications. Already we have seen the infix to postfix operations in the stack using array implementation, but now we are going to see additional applications. So as we have seen, the direct applications are page visited in the web browser, and the XML validation, it can be used for the some other data structures as a component. So infix and postfix that we have already seen in the first video itself. So the infix in the sense the operator present between the operands. Postfix in the sense the operands are present firstly, and then at the last only we are having the operators. So what is the logic behind this is the stack is used for the conversion of infix to postfix. So the output starts from the operands. What are the operands we are seeing, that must be added to the postfix expression. If you are seeing any kind of operator in the sense, it must be checked with the operator present inside the stack. If it is higher than the operator present inside the stack, means we need to push that operator into the stack. Otherwise we just pop the elements from the stack until the operator which is outside the stack is greater than the operator present inside the stack. So these are all the algorithmic steps. First, the stack is empty. When the operator arrives, it just pushed into the stack. If the left parenthesis came, means it just pushed into the stack. If the right parenthesis came, means we just need to pop the operator till the open parenthesis came. And then if the operator precedence is stack contains the less precedence means we just need to push the operator from the infix expression. If it is the equal or higher precedence means we just need to pop the element from the stack. At the end we need to pop all the elements. So when the operand comes, it just added into the postfix. If it is a close parenthesis, pop the elements until open parenthesis appears. When the operator comes, it must be pushed into the stack while the higher precedence operator is present outside the stack. Otherwise we just need to pop the elements from the stack. At the end of the input, we just need to pop all the elements from the stack. This is the sample expression. As we have seen already, A is passed, that is the processing of expression from left to right only. So first A is added to the postfix, and then star is pushed into the stack. When open parenthesis came, it just added into the stack, and plus is came, the open parenthesis which is lower precedence than the plus, so plus is added and star is also added. When the close parenthesis came, in between we are having B, C, D, that is added to the postfix. So when the close parenthesis came, we just need to pop the star and plus, because those operators are present until the open parenthesis came. So finally after the close parenthesis we just have only the star inside the stack, and then plus will come. The star is higher precedence than the plus, so star is also popped out from the stack, and then E came. After the E we are having the only element which is plus. So for example, if we need to process 8 minus 2 into 7 plus 6 by 3. So first 8 is added to the postfix, and then minus came, it just added into the stack. Then 2 comes, it just added into the postfix expression. Then star, the star is higher precedence than the minus, so added into the stack. Then 7 comes, which is added into the postfix expression. When the division comes, we need to check. In the operator plus come, we need to pop the elements like star and the minus, because when the operand is equal and the higher precedence, we need to pop those elements. So star and minus came from the stack, plus is inserted. After the plus is inserted, open parenthesis, then 6 is added, then division, then 3 is added. When the close parenthesis came, we just need to pop the the division from the stack, then the open parenthesis came, so the remaining one is plus present inside the stack. So that is come out when the whole operations is over, so the pluses came out. So this is the postfix expression. Okay, so this is the code. You can also try this kind of exercise. These exercises for the for the performance evaluation of infix to postfix expression. So this is the code. In this code we just need to find out the precedence first, which one is having the highest precedence. Here we have mentioned only the plus, minus, star and the cap. You can also include more number of operators. So based on that precedence you need to allocate the return value. So which one is having the highest precedence, that is started from 3, then 2, then 1, otherwise return minus 1. And associativity is whether the cap is means the associativity is left, right to left. Remaining things are left to right only. So we need to start from the string which is the infix expression. The for loop goes up to the length of that expression. If C is not the alphabets or the alphabets which is in lowercase and the uppercase, and the number means we just added to the result. Else if it is an open parenthesis, just push into the stack. If it is a close parenthesis, we just need to do the popping operation until open come. So that top elements will be added to the result. So finally the while loop is over until the pop operation is completed. And then if it is not SMT and precedence is lesser than the precedence present in the stack, and this is also left associative in the sense we just need to pop the elements. Otherwise after the popping of elements need to push, because until the precedence of the operator which is higher than the operator to be pushed into the stack, we need to pop the elements from the stack. And then the operator which has the highest precedence in the infix expression needs to be pushed into the stack. So after the pushing operation is over, if all the elements are processed means we need to pop the elements until the stack is empty. That is done in this while loop. So finally we just need to display the result. So in the expression we need to pass the infix expression. So this if case is for the operands checking. This else if for the open parenthesis, another one is for the close parenthesis. In this close parenthesis you need to have the while loop for the popping of the operands, and this while loop is to verify the operands precedence which is to be inserted into the stack is highest. And then this is the one kind of application of the stack, which is infix to postfix expression conversion. And next one is postfix expression evaluation. Evaluation in the sense, because infix expression means we can identify the precedence and the bracket to calculate the expression value. If you are having the postfix means we don't know where to apply that operands to find out the solution. So in order to identify the expression value of the postfix, we need to use the stack. So the stack is having, if the scanned element is operand, push into the stack. If it is an operator, we need to pop based on the operator whether it is a single operands used or double operands, unary or binary. Based on that you need to pop the elements. If it is a binary operator, you need to pop 2 elements from the stack, and that is evaluated by the operator and then push back the result into the stack. For example, 2 3 1 star plus 9 minus, you need to scan. 2 is inserted, then 3 is inserted, then 1 is inserted. After inserting 1 you are having the star, so pop the 2 elements 1 and 3, that is multiplied, the value is 3, that is inserted into the stack. Remaining we are having 2 and 3, that 2 and 3 we are having the operator plus, so the plus is evaluated. 2 plus 3, 2 elements are popped, so 5, the 5 is pushed back into the stack. After that we are having the 9, so 5 and 9 is pushed into the stack. After the 9 you are having the minus, so 9 and then 5, so 5 minus 9, which is minus 4. The first operator is the right and second one is the left, so the evaluated value is minus 4. So this is the postfix expression evaluation. So here is also in the evaluation we are having up to the expression size the for loop. If it is the expression, if it is a digit means we just need to push. Otherwise, we need to pop two elements. That's why value 1 is first element, value 2 is second element. So those value 1, value 2 which is given in the expression, which is the case. Plus means value 2 plus value 1. Minus means in between we are having the minus operator. That is evaluated, which is the top value is returned. We need to push back that elements to the stack. So after the evaluation is over, we are finally having the last element, which is the postfix expression evaluation. And here another one example is also there. One is balancing symbols. So first one is infix to postfix conversion, then postfix evaluation, and one is balancing symbol. Because if you are writing more number of instructions for the computer using higher level programming means we can't identify where the bracket is missed. So if many cases we are having more number of brackets, so in order to identify whether the bracket is correct or not, for that also we are having the program. In that program also we need to use the stack. That is the another kind of application. So in the parenthesis you just need to, if the open parenthesis, you just need to push that element into the stack. If it is close parenthesis, in the sense you need to pop the element until the next open is present. So pop in the sense we need to identify whether the popped element is similar to the element to be processed. If it is a match, then we can go for the next one. If it is any other mismatch means we can say that the element is missed. So until if all the elements are popped, for example, if you are processing this means first we need to push the open parenthesis, then close parenthesis will come. So when they pop the elements from the open parenthesis, these two are same, so the match is over. Then we are coming with the two open parenthesis, that is inserted. Then we are having one close. So for that one close, in the sense one operand, one thing is popped out. So one thing is popped out, then we are having two open, that is added. Another one we are having close parenthesis. So those close parenthesis popped out and the value is checked. Finally we are having one close parenthesis. So everything is processed until all these are all the stack elements present, and these are all the brackets to be processed. If you are having no elements inside the stack means the balances, the parameters are balanced. Parameters in the sense the brackets are balanced. So here also we are passing the expression which is equal to the length we need to process. If the empty in the sense temp dot empty in the sense we just need to push if no elements inside the stack. If it is open parenthesis and the expression is the close parenthesis, okay. So and the top is what different kinds of parentheses are checked here. If it is same, in the sense we just need to pop the element from the stack, otherwise we just need to push. And then if all the elements are popped and pushed, in the sense elements are popped from the stack, in the sense the parentheses are balanced, so we are returning true. Otherwise if it is not empty means some other parentheses are present inside the stack, so we are having we don't have the closed parenthesis for that. That's why we are returning the false. And the main use of the stack is for the function call and the call stack, because while you are using the recursive function you need to maintain in the activation record, you just need to maintain the return address and the parameters and the function name. So if the recursive call we are calling more than 10 times means we don't know where which function is returned. For those kind of application we just need to maintain all the functions call in the stack. So if one function is over means that must be written, that element is removed from the stack and the control over to the previous function. So till now if all the functions are processed means all the functions are returned means there is no element inside the stack. For example, bar is a separate function. Inside the foo we are calling the bar, inside the main we are calling the foo. So foo, first one is main in the stack, and then bar, foo, and then bar. So if the bar is returned means that is returned to the foo. If the foo is returned means that is returned to the main. So this is the stack operation. First one is main, and one is foo, and next one is bar. If bar is returned, next we are having foo only. If foo is returned, we are having main only. These are all the implementation. So in this video, we have seen the stack applications like infix to postfix expression and postfix evaluation and balancing parenthesis with the real-time example of function called stack. Thank you.